We're going to allow things just to get settled here in just a bit. Let folks kind of drop in, give them a few seconds. Hopefully people have started to come on. Okay, let's get this show on the road. Welcome, tech artists from around the world. Welcome to Tech Art Talk Live. My name is Chris, and I'll be your host for today's session. And today we are going to start the first of a six-part series, and we're going to be going over the fundamental Python that one will need in order to establish themselves as a visual effects artist, as a tech artist within the industry. Now, you don't need a lot, but still, in the overall grand scheme of things, there's still a lot of stuff to cover here. So I'm going to hurry up and get things going real quick, but I do want to say I'm really stoked and really excited today. I just finished my last technical chapter of my real-time visual effects for technical artist book, and I can not worry about my publisher coming down hard on me and cranking down and exerting its wrath on me. So I'm getting closer to the finish. So yay! Every little bit counts, right? All right, cool. Well, now you understand the reason for my levity. But with that said, let's get this show on the road for introducing all about Python basics with Houdini 18.5. All right, I'm going to change monitors here, and I bet I'm going to lose my video display. So, I lost it. So I'm going to go ahead and get it back. All right, we have my video display back. All right, the first thing you're going to want to do is go to the Houdini website. Now, if you already have Houdini, this is great. Now, I'm going to be working with Houdini 18.5, and I'm going to be broadcasting and teaching about Python 3.7. Now, 2.7 is very close to the same thing, and there are subtle differences. Now, I do have subtle, but there are some differences. So what we're going to do is I'm going to show you how to download and use Houdini with Python 3.7. Well, what you do is go over to the good old side effects website and then slap on over here to where it says support, get, then go to download. And then where it says download, you don't want to hit the download button because it's going to download the most recent production build version, which is not what you want. But what you instead want to go over here where it says production builds and click on production builds. Now, this will tell you something that they already are expecting, that this is the way of things to come. So just a little hint, hint, hint. Okay, notice that it says 18.5 production builds Python 3. Now it says in here that it doesn't say Python 2.7, it says Python 3. So they want you to use Python 3 here, folks. But this is where things are eventually going. So go ahead and choose your poison, whether you're working on a Mac, you're working on Windows, or you're working on Linux. Choose your poison, choose your thing, download that thing, and you might want to come back to this video at a later time and check us out and continue where we left off here if you haven't done this. However, if you have Houdini up and you're just like itching and chomping at the bit, this is almost the exact same stuff, and whatever I'm showing you today should technically work for your Python 2.7. Hopefully. If it's not, go ahead and text me or send me some information on the YouTube channel or email me directly, and I will go ahead and make the change. But I have a hunch that what I'm presenting today will transfer over to Python 2.7. All right, suppose you've downloaded Houdini, and now you're rip-roaring and you're ready to rock and roll. Now, you should end up with Houdini coming up here. Now, my window display is a little bit different than yours, but I created this for just the demonstration purposes. However, if you, worst comes to worst, what you have to do is click this little plus sign, and here it says new pane type, and if you want, go into where it says Python shell, then a little Python shell will work, and it will come up right here. But I'm going to change my thing around here. I'm going to leave this into a my network view, and I'm going to use this big old window for my Python shell, so it should be nice and visible for the audience. Now, the important thing here is you want to make sure you get the right version of Python, and in this case, you'll see that it says Python 3.7.4, which seems like a pretty good version to start with me. All right, and now with that said, let's get things rolling. All right, now if we go ahead and just type the number 8 inside of the Python shell, we hit it, and it just responds 8. And it says, okay, if we put 10 in here, it's going to replay. Okay, now if we want Python to behave like a calculator, we say 8 plus 10, and it's thinking for us. They say, ooh, 18. Ooh, very cool. Now, here's the difference. I'm going to be working with Python in both the interactive shell and with a Python script. They both are basically doing the same thing because Python, here it is, a little bit of computer science, is an interpretive language. And that means that it's already been compiled. That means when any Python thing is running, it's constantly hungry. It's looking, says, give me some Python, give me some Python, give me some Python. And it says, give it to me. And when you give it to him, it's going to immediately go, nom, 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 nom. It's going to eat them up, and it's going to do whatever it needs to do with it. Now, that's different when you working with a compiled language like C++. When you do C++, you got to go in, got to edit the stuff, then you got to save the file, then you got to send it to a compiler, and then, in the old days, you had to send it to an assembler, and then put it all together, an object generator. It was a mess. You don't have to do that anymore. With Python, it's already been interpreted, already been compiled for you, so it's just an interpretive virus, so you're ready to rock and roll. Okay, so we now know Houdini can behave just like a calculator. If you type in any kind of numbers in here, give it a thing like 9 divided by 24 times 498. Who knew? Well, anyway, we just figured that out. But it can get a little bit more fancier than that. So what we're going to do here is I'm going to go ahead and type in just a single line of code. Okay, this is a basic print statement. So this is a single line. I'm going to hit this, and there it is. Now you notice that this little text display has been indented. Why is that, you say? Well, notice here that in my little string, or that little bit in between the quotes that I have here for the print statement, I have a little \t. This \t is pseudocode for, I don't know if it's pseudocode, but it's for a tab. It's a tab escape character, and what this does is it inserts a tab here. We can't really see what a tab look like, but if anyone wanted to look like what a tab is, it's \t. Okay, so there we see a simple line, but if we wanted to, we could do a little bit more than this, and we could get nice and fancy. Okay, now look at this. I said, but we could do a bit more. Okay, so I have a little escape tab inserted before the but, and then here we got a special character, this \n. What does that stand for? That stands for a line return. Okay, in the old days, they used to have typewriters, and that means whenever you hit the line return, what it does is it would advance the roll on the typewriter 1 unit, and then slide the whole typewriter head off to the right, and you could start over and start typing some more, and that's what this kind of refers to. And then we have \t, put in 2 tabs and before we put in a bit more. Okay, so this is just a very simple thing of how you can use a print statement. You got to start someplace, right? Okay, the next concept that I wanted to start dealing with are variables. And variables are holding blocks, little buggers that do nothing but hold values. Okay, and they could be very, very abstract. And they have certain types, and they have come from different families, and they grew up in different regions. But let's not worry about that for now, because each variable can do, individual things. So if we say something like, first, this is my first variable, equals 36. And it consumed that, and it said, hey, okay, it didn't do anything, but did it do anything? So let's just type in the word first. We enter that, and it said, ooh, no, that's equivalent to 36. Oh, okay, so right now I have a variable inside of my Python environment called first, and it has a value of 36. If I put one in there called second, we say second equals 76. We enter that, okay, nothing happens, but if we see, okay, are you listening, Python? If I just type in second, Okay, then I have 76. Okay, now we're moving. Okay, we've got two variables inside of our system now, first and then second. Let's put a third one in there called sum. Sum equals first plus second. All right, nothing happens, but if we wanted to see what sum was, if we just type in sum, and voila, who knew? 36 plus 76, 112. Ha ha ha. Okay, now if we wanted to go ahead and print this in some kind of like fancy looking format, we could actually combine it with the statement that we were using before and in combination with something called a format statement. Now I'm going to go into this a little bit more in depth later, but let me show you what this says. So here we have print, and then inside of here we have the contents in between the double quotes. Everything in between the double quotes is what's going to be presented to the screen. Now notice here I've got these little placeholders, and these are like in squirrely brackets. Now, I'm going to leave those right there for the time being, and but I'm going. This string is then supported by this format statement, and then here we have the first variable, the second variable, and the sum variable. Now, when we put them all here inside of this format and then hit enter, lo and behold, it goes and inserts. Or every when you see one of these squirrely brackets, it inserts one of these variables, and in this case, first, second, and then the sum. All right, so that's how we are going to basically behave using the interpretive or the interactive environment. Now, Python can exist as creating little scripts that you can kind of store off because it kind of like gets boring and I don't really type very well very quickly. So this manual entry, at least for me, is kind of slow. What I'm much better at is creating scripts. So what you have to do is go in and create a new shelf for your Python scripts. And now if you've never used shelves before in Houdini, that's okay. I'm going to show you what to do right now. Now, if you are looking at someplace, you should see on the top, you should see a little bar on there with a whole bunch of tabs. Now, for me, since I'm working with a brand new session, there is nothing like that in here. However, you should see this little downward facing triangle. If you click that, you can see the options. A little menu comes up, and you want to get a new shelf set. So if we click a new shelf set, then hey, there's a new shelf. And if I wanted to, I can right click on that and okay, remove shelf set, edit shelf. I can click the edit shelf button. The little menu comes up, and where it says shelf 2, I'm just going to call it TATL for Tech Artist Talk Live. Ha ha ha. TATL. Now we are ready to rock and roll. Now, here's a whole bunch of other tools, but we're not going to worry about that. I'm going to click on that, click apply, and then accept. Okay, now we have a shelf just to do nothing but store our tools that we're going to create in our Python sessions. Now, to create the first tool, I'm going to click inside of this little tab, or right click in there, and say New Tool. Okay, here's our little new tool where we can first identify the name of the script that we want to create. And in this case, what I want to do is create a new script called, what is it do I want to create here? Okay, what do we want to call it? Oh, let's call add it up. Add it up. A little bit of a salute to the violent femmes. Thank you very much. Add it up. All right, now we could go ahead and click apply. And what this does is it saves it to the Houdini session. But we want to do more than that here. We want to click over here where it says script. Click into that, and we have a little interactive script that pops up there. And this is a little Python script. How do we know this Python? Well, it says script language here. It says Python down here. So we know that it's in Python. Okay, so I'm going to go ahead and create a new little script. And I'm going to actually type this whole thing in, and I'm going to show you what each of these things actually does. Actually, I don't expect you to follow along here. I only have really one person who's following along, and that might be me myself. But most probably you're looking at this video and it's a recording, so you'll be able to go back and forth and copy this stuff in your own leisure. So this first line, it says input equals raw input. Actually, I don't want raw input. I just put input, and I'm going to call this statement raw. Okay, raw equals input, enter the first and second values. Okay, so what we're going to do is enter two values in here, value A and value B. And then we're going to put this into this next statement. And so what this is going to do is it's going to assign values. Remember how I did was first equals one value and then second equals another value? Well, in this case, we're going to do both of them at the same time. But instead of putting whole numbers in here, we're going to do something called raw.split. Okay, the reason why we're going to do that is here. This input function is going to grab values from the display, and it's going to put them inside of this raw variable. But it's going to input them as to a one big old string, the first and second values. And so what we have to do is kind of split it apart. And so that's what we're going to do is we're going to tell raw to go ahead and split. And once it splits, we're going to say, okay, put your two values first, and then put the second one in second. And then in this line, what we're going to do is, believe it or not, these are, when we input this stuff, it's not a number. Even though it looks like numbers, they're actually just the numbers representing the actual numbers. What they are actual text values. What we have to do is convert those text values into actual computer stuff. You have to convert it into a computer number, and that's what I'm doing in this statement. And that's what this int function does, is what we're going to do is we're going to transform this first object from a string and convert it to an integer. And that's what this is doing here. So after this statement, first is now going to be the integer value, not the string value anymore. It's going to be the integer value of our first input. And then we're going to do the same thing for the second. And, oh, this isn't going to work. I have to change this. This is old version. Sum equals first plus second. Yeah, that's right. And then I'm going to say print sum equals, and then comma sum. If I hit apply, and then I'm going to move this Python screen over here. If I click accept, oh, yeah, right now if I want to execute it, I go ahead and I click on the icon. And did we get anything? Hello? Oh, I didn't get the thing. Oh, it was because, let's see. Okay, where is it? Okay. Okay, I have to find it. It's hiding from me. Okay, where are you, you tricky devil? Okay, I'm going to go ahead. It's actually, normally, yeah, let me see if I can find it. There's actually a text window. I'm going to click accept here, and I'm going to maneuver things around here a little bit to see if I can find that. Okay, and is it here? I'm looking for it. Oh, where is it? My little text window. Where are you? It disappeared. Oh, golly. Lo and behold. Okay, can I find it through here? No, no, no. All right, so click on here, edit my tool. Oh, edit up, it's gone. It didn't save. Well, how about that? Well, that's why you didn't get any output. It didn't save. So let me go ahead and retype this in. A lucky thing, I had this all stored. And we could just drop it right in here. And the only thing I did here was I turned this to raw. And I turned this here to raw as well. If I click accept, I click now add it up. There we go. Enter the first and second values. Okay, say 12 is the first value that I want to enter, 12. And then the second value is, well, 83. And we hit enter. The sum equals 95. Okay, it works. Very cool. All right, so that is our first introduction to our little Python world. I know that everyone does hello world as their first Python script, but instead of doing all that, I figured, well, let's do something just a little bit juicier because, you know, what we're breeding are tech artists of the world, and tech artists of the world do a little bit more than just do hello world. Okay, now some of you might saying, okay, we're doing some math in here. How do we control what the math is? Well, what the math is controlled by operators, and there's a precedence in there for the operators. And let me see if I can bring this up here. Boom, boom, boom. Is it here, 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 here? Okay. Dum, 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 dum. Oh my. There it is. Okay, there he is. The advance this slide just a couple. Okay, there's our precedence of operators. So this is how it's going to operate its stuff. Whenever it sees parentheses, it's always going to go, ooh, ooh, there's parentheses. I'm going to go do that first. You know, it's real hungry for parentheses. Then, if it sees this little star star, that stands for exponentiation. Okay, if you don't know what exponentiation is, then don't worry about it. You'll probably never see the star star. But for the rest of you who know what exponentiation is, like taking something to the first or second or to the half power or something, if it doesn't see any parentheses, it says, oh, okay, well then are there any exponents? And then it goes, ooh, cool, there's exponents. And then it goes gobble up, scarfs on those things. Now, when it doesn't find any exponentiation, then it goes into this level. Then it looks for multiply, divide, and this is a fancy old division again. And the last one is modulus. And so it does these operations first. It does a multiplication, it does a divide, and divide here, and then a modulus then too. And then it does these first in that order. If it doesn't find any of those, then it drops down into plus or minus, and then it goes into those order first. Okay, so let's get a little bit of practice creating this. So I'm going to go ahead and create, I'm just going to go right to the shell. And I'm not going to bother writing a script for this. Actually, I might just write a script just for just to make sure it looks good. So I'm going to create a new tool, and I'm going to call this new tool op practice. Op practice. Click over onto here, and let me get it real quick. Okay, there we are, gang. First we create 4 variables. A equals 2, x equals 5, b equals 3, c equals 7, and then we have this really complicated mathematical formula with all this gobbledygook, and then we're going to print out its value. So just for giggles, let's find out what this thing actually equals. I'm going to go ahead and make my window just a wee bit smaller, and then I'm going to click apply, and then I'm going to execute it by pressing this button, and it says 72. Okay, why in goony goo goo does this stuff all equal 72? Okay, so let's try to figure out what this equals. Okay, so before going into why, I'm going to just kind of change things up a little bit. So I'm going to put a comment here so that we don't actually see it. But let's see what this actually kind of corresponds to. I'm going to say y equals, okay, let's go for the operator. Are there any parentheses in here? No, we don't see any parentheses at all. But we do see an exponent. And so it says a times x star star 2 plus b times x plus c. And then let's just do it. What's this? That means it's a times, okay, x times 2. X is 5, and we take 5 to the square power, then that's 25, right? And then we want to add b, and then multiply it by x again, and then we're going to add c. Now, if we execute this, we still get 72. Okay, so we did that first step for us. Then we're going to start looking for multiplications, because multiplications are the next in line here. So here we go with a to this. So I'm going to look over here. I'm going to comment this out. And I'm going to rewrite this again, but in the order. So the first thing we see is A times 25, and A is 2, so that means this A times 25 is 50, and then plus B times X. Now B is 3, X is 5, so what's B times X? That's 15, and then we're going to add C to it. And let's just check to see if we get the right logic. Apply, append, and it's still 72. Okay, well then now we know that it's 50 plus 15 is 75. Wait, 65, and then plus 7, that's 65 plus 7, that's 72, and that's all equals 72. Okay, so that's how that equals. Now let's do another example real quick. And I'm not going to go into as much detail here, but now look at this. We have z equals all of this gobbledygook, and now we have a parentheses, and we have a division, and we have a modulus. So if we were interested and say, okay, what does this all equal? So print, you can actually go ahead and break this apart at home. If you're watching at home, you can look at this and say, ooh, I'm going to go stop all the tape. I'm going to try this by myself. And just so you know what it means, if we take a look at this, hit apply. Okay, the value is 1. Okay, so if we go ahead and break this expression down into its full thing, it's the value of 1. All right, so that is how we do math in Python according to these operation rules. Very fascinating. Okay, now let's go back to this whole string thing. Notice that we have double quotes here, and this is what's called a string. Anything in between double quotes is considered as a string. Now, in Python, there are three basic critters that we have to deal with when dealing with strings, and that's 3 various types of quotes. We have double quotes, and it's going to go, well, I don't like that because you got to do stuff with it. But if we have quotes, then it understands that. And if you have single quote, it understands that. And here, check this out. You can also do triple versions. So triple, 1, 2, 3, and then 1, 2, 3. Okay, that's 2 sets of 3 single quotes. And it says, okay, that's fine. And we can do the same thing here. 1, 2, 3, and then 1, 2, 3. Okay, we now have that. So it means all basically the same thing. And so with that, you can actually mix and match and start getting some practice working with quotes within quotes. Now, you're probably saying, well, that's stupid. Why would I ever put a quote within quote? Trust me, it happens all the time, and you want to keep on dealing with it. Okay, so if we go over here and here show this, so this is another string within double quotes. Click on that, and there it is. So instead of double quotes, it's actually single quotes. Okay, but what if we wanted to actually see the single quotes in here? We couldn't use that technique. We'd have to surround it by double quotes. So here we have the single quotes in there. Now you're going, hey, what's up with that? What I did was I used this backslash as an escape character. Now this escape character enables you to kind of like go ahead and sneak something in and use something literally. So whenever you see backslash in there, it says, okay, use this literally. And so I want a single quote in there. Now, if I forgot about, oh, what's that way of escaping that Chris mentioned that I can't remember, what you could do is just surround your quote with the quotes that you aren't using. So if I wanted to see the single quotes, then I would surround it with double quotes. And then you see we actually see the single quotes in the statement there. And so this could go on. We could use the double quotes. And then you notice that we're using the triple quotes in order to see double quotes and single quotes. And you'll see both of the styles work. And they're kind of like interchangeable. And so here we notice that we used 3 double quotes at the end, and here we're going to use 3 single quotes. And so we have that. All right, well, that's really all you need to worry about when dealing with quotes. Now, let's go back to the string thing again. Now, when we had it, okay, there are a bunch of different ways of formatting your strings so that they look proper on hand. I'm going to go through just one format on here, and that is, if you want to print something, it looks like this: print, and then in here you put something inside of a double quotes, dot format, and then whatever you want to get stick in there, you put it inside this format statement, and then it clicks in there. Now here, it's not going to do a whole lot of anything, but we could do it with a whole lot of extra stuff. Now here's getting back to what we worked with originally way back when. So this is a blank, and notice here that I want to say, put something in here. And I don't know what I'm going to put in there yet. So I'm going to just use squirrely brackets for that. Okay, this is a blank of a blank and a blank. Notice that wherever I said blank, I'm putting curly brackets. So I said put format. In the example here, this is a string. So what we're going to do is we're going to put this string into this first one. 84 is an integer, and we're going to put it into the second one. 6.9 is a float value, and we're going to put it into the third. Okay, so there you can see here is it assembled everything appropriately. Now, Python does allow you one convention where you can say you can scramble things up a little bit, and that is go ahead and put numbers inside of those little squirrely brackets. And then when you put the format statement, everything looks exactly the same. But then if you put numbers in here, you can kind of change the order of things, and it doesn't have to worry sequentially. And so here you see this is a 6.9 of a 8.4 and an example. Okay, that really doesn't, but it just shows you that you can kind of mix things up if you kind of change your mind after you've created this statement. Okay, the next thing I wanted to do is Python is really good at evaluating if something is true or it's false. So if I say something like, okay, 2 is greater than 3. Ooh, Python knows that I'm lying. It's sharp. But if I say 3 is greater than 2, it says true. Oh, so it knows what if I'm telling the truth in here. So let's keep it sneaky here. Let's say 3 equals 3. What does it say about that? Uh-oh. It says syntax error, can't assign to a literal. Ah, okay, so we're using the wrong critter to do evaluations, because this evaluation, it doesn't use a single quote. So what we tried to do was assign the value of 3 to a value of 3. And now, technically, logically, we know that that works, but as far as Python is concerned, that's just gibberish. So we have to use it in terms that Python likes. And instead of using equals, use equals equals, and then 3. And then, okay, does 3 equal 3? And it says, yes, definitely it does. So that is really good because a lot of it is dealing with it. So let me go ahead. I'm going to display what I consider is the operators that we're dealing with when dealing with expressions. And let me pull this up here. Aha. All right, there's our operators. Let's move on just a little bit. All right, here we go. So when you want to compare greater than, then you use the right arrow. If you want to do less than comparison, then it's a left arrow. Greater than or equal to is done by a right arrow with an equal sign after. Less than or equals is done by a left arrow and an equals. And then we've already saw this. If you want to do equals this, then you'd use the double equals. Now, if you want to check out if something is not equal, then you use the bang equals. Yes, I know that's old Unix. The exclamation mark is called bang. Yes, folks, it is. Okay, or if you don't remember that, then you can use the right and left arrows and put on here. And if you're putting together some formal logic, you can also put in the word not. And that just means that negates whatever you have here. And let's see, let's give an example of what we could use as a not. Okay, let's say 3 equals not 4. And so, okay, so that is going to work, but let's just say 3 equals, so let's just say foo equals 3. Okay, so 3 equals not foo. And it's still, okay, so I'm not using it in the right context here with the right here, but not is ultimately used to negate something. And we're going to show you how to use that here in an if statement here very, very soon. Okay, now if you're using the if statement, it goes into this particular format. Okay, it's always created with an if word and then an expression that we had just evaluated here. We've gone through, okay, you can create an expression. Now here, this is important. In Python, they don't use the little squirrely brackets in order to create blocks of text. Instead, they use indention. And so if they're using indention, well, how do you know what the end of the line is? Well, that's where they use a little colon. So the colon here designates, they say, this is the end of the line. So if we have here, this is a colon, and then we indent, and now here's our block of text, and it goes right in here to the command. And so if we have an if, what we could follow it up is with an else, and then another command. So if this is true, then do that, then do this, else do that. Or you could put an else if, and they kind of scrunch those two words together and they say elif. Okay, if this expression is true, do this. Else, if this expression is true, then do that. Otherwise, else, do this. And that is how it all goes. Okay, so let's call up a new if example. All right, let me go back. I've got that. Let me go back to my Houdini. Okay, cool. I'm going to create a new tool, and I'm going to call this if. And I'm going to call this if. All right, so create the script. All right, so I'm going to pull in my input again for the first and second values. I'm going to do all that before. But now, instead of just printing them or adding them up, I'm going to compare them. In my first statement, I'm going to say, okay, does x equal y? If it does, then I'm going to print, okay, cool. Hey, x equals y. Right. Now, if that doesn't work, then I'm going to go on to this statement. It says, else if, okay, is x greater than y? Now, if x actually is greater than y, then it's going to do all of this gobbledygook. And if all else fails, if everything doesn't work, then it's going to go back and it's going to say, then print this is less than that, because really we don't have any more options, and that's pretty much it. So let's go ahead and apply this and go ahead and run it. Okay, enter the first and second values. Let's enter 3 and, well, let's say 3. See, in 3. And say 3 equals 3. Okay, cool. Python knows that 3 equals 3. Now let's do something again. Now let's put in a value of 2 and 9. All right. It says 2 is less than 9. So what it did was all of these two expressions failed. And then when it finally said, okay, I've got no more expressions to it, then it just defaulted and say, okay, fine, just give me the last one. And it says 2 is less than 3. 2 is less than 9. But if we were to do this one more time, but with those values switched around, we'll go 9, 9 and 2. Okay, 9 is now greater than 2. Okay, then we know we're in good shape, and we know our if statement is working well. Okay, now we've done a lot of basic stuff with basic Python, and you can say, hey, I thought we were going to be using Houdini, and I thought we were going to be doing some graphics. Okay, let's go ahead and do some graphics here. Okay, so I'm going to go and create a brand new script here. And I'm going to create a new tool. And then I'm going to go and call this sphere. Keep it simple. I'll click apply. I'm going to move this over onto here. Okay, I'm going to move this over here. And so the first thing I'm going to do is I'm going to create a node, or I'm going to create a variable that corresponds to my network view. And you say, wait a second, can you create a variable to actually hold the network view? Yeah, and that's exactly what I'm going to do. And so here it is, object node equals who.node/obj. And look at behold, we see /obj is right up here. We go, oh, okay. So this whole network here is, according to Houdini, is called /obj. So yeah, give me /obj. If I click apply, if I hit sphere, okay, nothing happens. Well, that's pretty much what I expected it. Okay, now what we want to do is okay, in this network here, what do you have to do when you create Houdini? We first got to create a geometry container. And so that's what I'm going to do first here. Okay, I've got a geometry container here. So I'm going to say my new container equals object node. We're going to go create node. So whenever we see in Python, whenever we do a dot, we see a variable name and a dot, and then some kind of command or function. That's exactly what it is. It's to say, okay, now do this. Okay, we have to say like, okay, variable object node, go ahead and create me a new node. Now, create node is a function that's supplied within the class. Now, we'll be going into that in a couple weeks, what all that means. But we're just saying, like, okay, you network you, go ahead and create a brand new node. What kind of node? Create a geo node. Okay, well, that's what a geometry container is called. It's called a geo node. And why don't you call it sphere geo? If I click apply here, I click sphere. Hello. Accept. Come on. Give it to me. Did it create something? Is my Houdini session dead? There we go. Now it's doing. Do I have anything in here? Can this actually create a geometry? Hello? I mean, is it too small? Oh, gosh, look at that. It's all dinky. Oh, there we go. Maybe I couldn't see it here. Okay, so we go ahead and delete it. Now let's see if this works. Click apply. Okay, so it is not creating here. So do we have anything on here? I'm going to move this over here. Do we create anything? I don't see anything. Oh, this is terrible. Okay, so let's see if this all works if we work in here into this. If I say, all right, obj node, C, always count on your demos not working. Hey, but that's why we're watching live, right? So we can see Chris mess up here, huh? Okay. All right, so we're going to do the same thing here in the shell. Oh yeah, and we're going to do the same thing here. Now click onto that. All right, container equals obj node creation here. And did it do what it's supposed to do? There it is. Okay, now why it didn't work in my function, I don't know. So I am just going to say, okay, screw you, I'm going to delete you. And then I'm going to go and create you from anew again. Okay, say new tool, options, sphere, dang. Sphere. I don't call this sphere. I mean it, daggone it. Script. And then I'm going to put these two values in here. I. Oh, it's just not being cooperative here. We are just not having a good day here. All right, give it to me. Give me my text. My cut and paste has suddenly decided to fry on me. Cancel. It is not having it. All right, so let's just keep going here, keyboard interrupt. Let's just keep going on it. Okay, we've gone and we've created a container here to contain our node, right? Let's do this. Okay, there's our container. Now, if we drop inside of that container, nothing's in here. So what we have to do is literally do the same thing in our script. We have to drop inside container and then actually create something. And what do we want to create? Well, let's go ahead and create a sphere. So I'm going to say here, sphere equals container create node. Now notice that instead of, we're not using obj anymore, we're using the variable container, because really what this did was in Houdini, it created a new out node, but it also assigned that thing to this value of container. When we say, okay, then use this value of container, then have it create a new node, and I want to create a sphere node, and I'm going to call it my sphere. Okay, there it is, my sphere. Now notice that we are still here, and this is our object. We double click in here and it says my sphere. Okay, well then we should be ready to rock and roll here. But there's still one additional thing, is that this is a primitive sphere, but I want to make sure that this is a polygon sphere. And how do we change it from a polygon? Well, here's a little tip. If you put the cursor over the attribute name, then you look over there, it says parameter type, and you see it says type and it says the actual name, type. All right, that's what we got. And then we click over here, and then we notice that there are 1, 2, 3, 4, 5, 6, 7 options. And so knowing that computers start counting from 0, we could go 0, 1, 2, 3, 4, 5, 6. And then we can say, okay, Mr. Primitive here, I don't want you anymore. I want not the 0th one, but I want the polygon one. So I could then go and just type that. Is this, okay, sphere.parm. So here it is. I have my sphere. And let's turn this back to here. And then I would say, okay, go to the parameter called type, and then set its value to 1. Now, if we go ahead and click that, you'll see that it immediately turned that over and changed that from a primitive over to a polygon. You say, okay, well, that's all right, but I'm not going to be able to remember all those sequences, which is valid. You may not be able to remember it all. So let's go ahead and create a script, and then hopefully the script will work. Maybe we just don't like spheres. Maybe instead, let's see if we like Roberto. Now, who doesn't like Roberto? All right, here I have my Roberto script. So give me some Roberto. Let's do the exact same steps that we did before, but instead of creating a sphere, we create Roberto. If I click on script, in there, I click paste, and then I have all my values. So this is the exact same script that we did before, but instead, we're going to create test geometry rubber toy. Well, that's the alias that Roberto goes by when he's not fighting crime in the Houdini world. If I go ahead and click apply, and then if I click Roberto, there we go. We get Roberto. Now, why it wasn't working for the sphere, I haven't the foggiest idea. Maybe if you know what I was doing wrong, you can email me and say, hey, Sluggo, you forgot to do this. Yeah, that would make my day. But anyway, we have Roberto here, and it's done created the exact same thing. So we now have a script, Python-driven Roberto. Isn't that fun? All right. I'm going to click accept here. Sorry, Roberto, got to get rid of you. Got other concepts to go along here. Okay, now if you wanted to do things multiple times, which is really useful for creating any kind of programming language, what you're going to have to first do is a while. A while, you say, what are you talking about, a while? Okay, what you're going to do is create a while structure. So we have our if structure, but what if we wanted to do something a bunch of times? We covered a lot of stuff. Oh, we're going backwards. Not good. Okay, a while structure. in order to create a while structure, we first have to create a break. And a break is some variable that we can do an expression on. It says, okay, can we do this expression on break? And then while this expression keeps on returning true, then we're going to do this body. And then every time that we finish going through the body, then we are going to put on a new value for this break. And then once it goes down here and it says, okay, we've adjusted our break value, then we're going to go back up to this expression of where it evaluates the value for break. And then it's going to look at that. Okay, is this expression true? If it is true, then we go through this whole process again. And we keep on repeating over and over and over until finally there comes to be a state where this expression is false. And when it's false, that's when it kicks out. Okay, let's create a very simple example. Suppose we wanted a whole bunch of spheres. Yes, we're going to try this again. We're going to try to create some spheres and see if Houdini plays nicely with us this time. And I'm going to call this more spheres. More spheres. Okay. Oh, that's terrible. Look at that. That's not spheres. There, that's spheres. And here, more spheres. Okay, that's better. Okay, here what we did here is, here's our object node right up top, and now here I installed my break. I say, okay, break equals 5. So basically, I'm going to create 5 spheres. And then what I'm going to do is I'm going to create a name. And now here, I put it in quotes. Now notice here, I didn't print it out. What I did was instead, I put the result of my quotes here, not inside of a print statement, but I put them inside of a variable content. I said, ooh, let's call it name. Okay, then I said, okay, fine. So let's create our geometry. And so here it is, my geo container equals object node, create node. We're going to create a geo, but instead of putting the name that we wanted in here, we're going to actually put name. Ooh. We would put that value here. We're going to slap that in there. So let's go ahead. Then we're going to move our container, or create our container. And we did this, create a new sphere, and call it my sphere. Okay, that's fine. Now here, we assigned it to the sphere variable. Now here, what we're going to do is we're going to convert it to a polygon. But here's a new one. We say, okay, for the new parameter, the translation of x. Ooh, we're going to set that translation of x value. We're going to set it to 2 times break. Okay, that's interesting. So the first one, if break equals 5, that's going to set the translation of x to 10. If we go through this again and it gets a little smaller, then it's going to keep getting smaller. And in fact, after we get done creating our sphere, then we're going to adjust our break. You know, here it says break minus equals 1. Okay, minus equals is a very fancy way of saying break equals break minus 1. You get into those habits, you create those shortcuts, and then suddenly you're not thinking about it any longer. But what this does is this decrements this by 1 by break. Okay, so the next time it goes through is 4. Then it goes through, it creates another sphere, and then it calls it set 2 times break. So it's going to move it 8, and then it's going to go through again, and it's 6, and then 4, 2, and then 0. So we should end up with is 5 spheres all in a line. There they are. And if that's not true, take a look at this Houdini display. We should see there are 5 spheres now sitting right here, and they're all called 1, 2, 3, 4, 5. All right. Now, while loops are good, but the thing about while loops is that they, if they enter it, they have to go and they don't have to do it once. If you want a little bit more control with your while loops, because while loops are a little bit dangerous. Why? Well, because this break value, what if you forget to set your break? Well, then this loop keeps on going forever. Now, if I wanted to really be insidious, I could just remove this little line here, and then my machine would crash. Why? Because Houdini got into a mode where it's just started creating spheres. And then after it got done creating about 32 million spheres, Houdini is going to crash and it might actually bring down the machine. And I don't want to wait until it does all that. So let's leave whiles out. So instead of using whiles, you might want to use something called a for loop. Now, a for loop is real interesting. For loop kind of like looks like this structure. I'm just going to go ahead and I'm not going to show the text. I'm just going to create a brand new thing. I'm going to call it for loop. For loop. Okay. Okay, what the thing is, we say for, and then we create some kind of variable. Okay, that's fine. In, and now here where it says after in, we have to put in something called a sequence. And a sequence is a set of numbers. And now here you can see what it's in between in between these square brackets. This is my sequence. And here we're going, okay, do this thing for the value of 1. And so what it's going to do is going to put this value inside of the variable counter, and then it's going to perform this function. It always says print counter. Well, that's not going to work. There, that'll work. Then once it finishes with that, it's going to go through and then it's going to put this value 2. It's going to put it in counter and then it's going to go through and then plug on this value. It's going to do is 3 and then it's 4. If we could click apply, and we go for loop, notice that it printed 1, 2, 3, 4. Now, it doesn't have to do that for just numbers. What you want, if you could do it for strings, or for every element that's in this sequence, it would work. So let me give you another example here. Okay, for Spud in Jerry, Mark, Bob, Bob 1, Bob 2, and Alan, we're going to print out the Spud. If we click apply here, and we hit the for loop, and you devil here, I'm going to cancel you and create another group, another tool. I'm going to call this for loop 2. I'm not going to even dork with you. For loop 2. Call this for loop 2. Isn't live broadcast just so exciting? So many interesting things can happen. Well, I click apply here, and now hit for loop 2. And then we have Jerry, Mark, Bob 1, Bob 2, and Alan. So whatever you put inside of this sequence here is what's going to get put inside this variable, and this is what it's going to get fired down here. Now, what if you don't just want some numbers, and you don't want to list out all these numbers because you're going to go through this whole routine 68,000 times. You don't want to create one big old sequence with 1, 2, 3, all the way to 68,000. What do? Well, then you use something called a range function. And if we say range, okay, remember I said we're going to turn it, so here we go, range. And if we go, okay, we want to put in a value, to count all the way up to 10. So let's see what 10 was. Okay, say list range. So it's going to create a new sequence for us. It's going to start at 0. And remember I said computers always count at 0. So it's going to go through 0 all the way to, the number -1. Okay, that's interesting. So it didn't actually go up to 10. It went up to 10 minus 1. Okay, I'm going to have to remember that. So if that's the case, then there's another way of doing this. And you can put a start value in here. Let's put like -3 and then 7. So what it's going to do is count all the way from -3 to 7. And there's our sequence. Okay, -3, -2, -1, blah, blah, blah. And notice that it stopped at the 1 minus or 1 below our endpoint. Okay, cool. Now, if we wanted to, we could also do by increments. And if we do by increments, here we did, because I could count from 0 to 20 by 2s. Ooh, it goes 0, 2, all the way up to, once again, n minus 1 here, and that's, okay, what's that? That's 19, but it didn't really go up to 2, so it just dropped here to 18 right away here. You see? All right. So how does this apply then if we wanted to apply this to some good old Houdini stuff? All right. And I'm going to call this new tool, and then I'm going to move this over here. I'm going to call this multi-Roberto. And let's see, multi-Roberto. And I'm going to get rid of that. Okay, I'm going to put one more script up here. All right. So what we're going to do is we're going to create Robertos again, but here we said range 5. Okay, so that means this is going to return a sequence that's going to count 0, 1, 2, 3, 4. And then we're going to do the same thing that we did here with the spheres, but instead we're going to create a bunch of Robertos, and then we're going to modify their translation of X, where it goes from first translate from 0, and then 1, 2, 3, 4, and it's going to create 5 Robertos here. If I click apply, click multi-Roberto, and there are our Robertos. Isn't that nice? Now, if we look at each one of these, we'll notice that each one has been translated a specific amount. So if the first one hasn't been translated at all, this one's been translated 2. And it's making me a liar. Oh, that's because it's actually not done on this level, folks. That's why. So if we come down here, I forgot, it's down here in this level. If we look at that version of Roberto, and there's our 6. So it's been located 6, and the next one would have been translated at the value of 8. Okay. Well, that is what I wanted to go through. I know that we covered a lot of stuff here today, and this is a lot of really good stuff. But, learning Python, it's going to take a little bit of time and a little bit of effort. If you go and practice these things, if you don't like Roberto's, you like Squidward instead, you might actually put in a whole bunch of Squidwards and then say, hey, man, I just made a whole bunch of Squidwards. Check this out. So that would be lots of fun, too. Okay, well, this is all I wanted to cover today. So thank you very much for joining me with this thing. If you like what if you want more of this stuff and you want more Houdini stuff, come on and check me out at Houdini Secrets Live this afternoon on the same channel. And we're going to going over is Vertex Animation Textures 2. We're going to be dealing with rigid bodies. Now, last week we did soft bodies. Now we're going to do this week, we're going to do rigid bodies. Ultimate, really, really, really powerful stuff. And then next week, what we're going to be dealing with, and that's going to be on the 5th of February, we're going to be dealing with Python functions and data. Now, we kind of went over a little bit of that today by default, and I actually wanted to actually cover it officially for you folks next week. And we're going to go into more Python functions and data. Okay, if you like what you saw today, please go ahead and subscribe to this channel. And if not, then, go ahead and check me out. I'm Chris Rhoda. Check me out on Facebook and on LinkedIn. And if that's not cool, then come over to the TechArt EDU and check out that on Facebook and LinkedIn, because we're there too. But honest folks, if you really want to help me, this is how you can help me. Go over to my website, techartedu.com. And that's where I put all of the postings of updates of what I'm all up to. And if I give away any kind of goodies that you can download, that's where everything is going to be. And I can create any links. It's all going to come out of this particular website. If you would please go to this website, and then when you see this little kind of get access to the latest articles, go ahead and click here now. When you go ahead and click here now, you're going to put in your name and you're going to put in your email. And what that does is it's going to put you on my email list, and I'm going to keep you in contact. And whenever I have any changes, you're going to get updated immediately that, hey, Chris has got some contacts over, has some changes over at TechArt EDU. Let's go check them out. All right, that's all I really wanted to deal with you folks today. Thank you very much for joining me. And if you can join me for Houdini Secrets in a couple hours, I'll see you in a couple hours. If not, I'll see you next Friday. And until then, arrivederci.